So the next thing I put in is expected, right? So there's my observed. Now I'm going to put in the expected, and it's nice. All. So it'd be 0.2 times 500, bam. 0.3 times 500, bam. 0.35 times 500, bam. 0.15 times 500, bam. And to make sure real quick, what should all these add up to be? 500. And they do. Okay. How we doing so far? I mean, that's the numbers you got, right? Yeah. Yes, okay. And then L3 is going to be L1 minus L2 squared. So it'll be, I can make L3 equal to L1 minus L2 squared. So does this match up with what you got? Is this what you got? Okay. And then L4, show me what you got. L4 is going to be L3 divided by what?
L2.
L2, I like it. You're expected, right? If you don't like the calculator, you don't have to use it for this. The lists, but I mean, I just want to show you. Divided by what it is, say L2. Bam. And that's the numbers you got there? Maybe?
Yeah.
Yes? And then I can go, if I wanted to I can go to list some. Oh, I want to get out of there first. Sorry. List some L4. 106, sorry.
This
Does this agree with you?
yeah.
So I'm not sure what happened back there, Lance.
Yeah, I messed up.
Somewhere, yeah.
I got it.
Okay. So I get this sum.
I sounded like
Alright, so what is this?
chi-square star.
I like it, chi-square star, I like it. So we got chi-square star. Now, how do you guys get the chi-square to compare that to? The rejection region chi-square, the chi-square critical. That's what the textbook. Yeah. So we know that alpha is 0.01. We know that n is what?
3.
N is 4 categories. Degrees of freedom is 3. I like it. Should feel very familiar. So I mean, the chi-square chart is different. It's going to take a little getting used to, but this is a little bit different because it's not the number in your sample. It's just the number of categories. Right? So don't say like the first one we did 38 students. No, it's only 5 categories. Degrees of freedom is 3.01. Stop at 3, and I get 11.345. So if I drew this out, it would look like that. I need 11.34. What was it? 5. There it is, Jeff. And we got 106. Blah, blah, blah. So, do you think we reject that these are the same?
Yeah.
Yeah, we killed it, right? This is very, very different. Nowhere near to being the same, right? Way in the rejection region. So therefore, the people that are living in this little secluded area, is their blood cholesterol level very different from the normal population? Yes. Very different. So that's evidence that these two things are different. I like it. Yes, sir.
So how would we answer that word? Does this group match the general?
Does this group match the general pattern? No. We have found evidence that they do not match the general pattern, that they are very different. Then I would go in and investigate further and try to determine what it is. Is it their diet? Is it their exercise? Is it the air? Is it the water? Is it some little bug that got mutated and bites everybody? I don't know. Are they drinking plutonium water? Nuka-Cola. Yes, sir.
So if it is in the rejection region,
You found evidence that the two things are different. That one, the one you're looking at does not follow the expected pattern or the general pattern. So this problem is, this is known through medical records or something. Now, to be honest, I just made this up, but this would be known through medical records what the expected pattern is. And then we find some little group of people and we say, okay, let's compare this. And they're very different. And then we suddenly get very interested. We're like, what are these people doing? No? Maybe? They're not eating Cheerios? What? Cheerios? Cheerios is bad for you kids. Commercial say it's bad. Yes.
So the number fell like within
no, we
the normal destroyer,
that's because
then we
group back in general.
So guys, if I calculated a chi-squared in here, then we have not found evidence to say that they are different. Yeah. So it looks like they might be the same. Right? We fail to reject that they are the same. Right? Does it make sense? I know the wording is a little weird. We fail to reject that they're the same, so we can't say that they're different. Because again, what does 0 mean? What does this 0 mean? If I got a chi-squared of 0, that would mean that they match perfectly. So it should make general sense that the further I am away from 0, the less they match. And just for the same exact reason that I can't just say, well, the gas price, they thought it was $3.60, but we found a sample with $3.61, so it's different, so I'm done. No, it's just a sample. I got to see if it's different enough, and that's what this number is. Is it different enough? So this is just like the 1.645 or the 2.576. Do those numbers sound familiar? And then you calculate a number and see where it falls. It feels so, and I'm not going to make you do all the steps. You just have to do exactly what we did here. Sure, okay. I at least wanted to expose you to the chi-square distribution. There's a lot more you can do with this. So if you're going into psychology, anybody going into psychology at all? Yes, you're going to use a lot of it. Business sometimes uses chi-square stuff. Business peoples. Nursing, I don't know if you really use chi-square. Probably not. Yes, sir.
Since you're only doing 11.1 and 0.2, does that mean we're going to do those for the homework as well?
Exactly. So I don't know if you realize this, but we basically just finished all the material for the whole semester. Because what's happening next week, I'll tell you this. Yeah, on Wednesday of next week will be review. On Monday we're having a quiz.
On this?
No, not on this. I never do that to you. Quiz on correlation and regression. Right, the chapter 12 stuff. So on this quiz, you're going to do it, and then you're going to come up and show me, when you calculate the scatter plot and the line of best fit. If you can't show me both, you won't get credit for that part. Yes, ma'am. This coming Monday, yeah. You guys realize next week is the last week of classes, and basically week after that is finals? Yeah, correlation and regression. The reason they call it regression is you regress towards the mean, right? So it's about how close to the mean do you get the mean as the line of best fit. So that's the AX plus B stuff and the R stuff. Say again? No, correlation tells you how strong the relationship is, and regression is related to that, but it deals more with the line of best fit. Yeah.